Every single night, your brain does something science still can't fully explain. It creates entire worlds, people, and memories that never existed, while convincing you they're completely real. The strangest part? Some scientists think the answer might lie in one of the weirdest laws in the universe. You close your eyes, the room disappears, your worries dissolve into silence, and then you enter a state that neuroscience still cannot fully explain. You dream. For centuries, people called this a message from the gods, then a window into the unconscious mind. Now, a small group of physicists is asking something far stranger. What if consciousness, and maybe even dreaming, runs on quantum physics? Most scientists think that idea is wrong, but the reason they think it's wrong is almost as interesting as the theory itself. Stick around, because by the end of this, you'll understand exactly where real science ends and speculation begins. Here's the problem mainstream neuroscience still hasn't solved. We know neurons fire. We know signals travel. We can watch it happen in real time on a brain scan. But nobody has ever explained why any of that electrical activity should feel like anything at all. Why does a pattern of neurons produce the experience of the color red? Or the strange dreamlike logic of a nightmare? This is called the hard problem of consciousness. It's not fringe. It's one of the most debated open questions in cognitive science. And it's exactly the gap that one controversial theory tried to jump into, a theory involving your neurons. And something borrowed straight from quantum physics. Here's where it gets genuinely wild, and where most scientists start shaking their heads. In the 1990s, physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that tiny structures inside neurons called microtubules might host quantum effects, like superposition, where something exists in multiple states at once until it's measured. Their theory suggested consciousness comes from these quantum states collapsing in a coordinated rhythm across the brain. Not a metaphor, an actual physical mechanism. It sounds almost too elegant. And that's the first red flag scientists point to. Because here's the catch, nobody in the headlines tells you. Quantum states are famously fragile. In a lab, physicists need temperatures near absolute zero and near total isolation just to keep a quantum state stable for a fraction of a second. Your brain is warm, it's wet, it's noisy. Trillions of chaotic molecular collisions happen every second. Critics, and there are many, including most physicists working on quantum computing, argue the brain is about the worst possible environment for delicate quantum states to survive. Not for seconds, not even close. So why does this theory refuse to die? Because one detail keeps nagging at people who've looked closely, and it has nothing to do with microtubules. It's not the physics that keeps people curious, it's the resemblance. Quantum systems behave in ways that break our intuitions. Particles in multiple states at once, outcomes that stay undecided until something interacts with them. Dreams behave the same way. In a dream, a room can be two places simultaneously. You can be two people at once. Time loops, skips, contradicts itself, and none of it feels strange while it's happening. That resemblance is not evidence. Scientists are quick to point out that a metaphor is not a mechanism. Just because two things look similar doesn't mean one explains the other. But it does raise an honest, unresolved question that no one, skeptic or believer, has fully answered yet. If quantum effects aren't driving consciousness, what is? Because the leading alternative, that consciousness simply emerges from enough neural complexity, hasn't fully explained the hard problem either. It describes the how. It still doesn't fully explain the why it feels like something. That's the uncomfortable truth most people never hear. It's not that neuroscience has a solid answer and quantum theory is a silly outsider. It's that neuroscience doesn't have a complete answer at all, and quantum consciousness is one attempt, likely wrong, at filling a real gap nobody has closed. Tonight, you'll close your eyes again. The room will disappear, and for a few hours, your brain will build entire worlds from nothing, using a process science still can't fully explain. Maybe it's quantum. Almost certainly, it's not. At least, not the way Penrose and Hameroff imagined it. But the mystery underneath it is real, and it's still unsolved.